Okay, chemistry, we're going to spend this lesson talking about some of the ways that an atom can be changed. So we talked about Rutherford's gold foil experiment, and one of the things it discovered was that an atom is mostly empty space. So if you put the nucleus of a helium atom floating above the middle of San Diego Stadium, which no longer exists, the stadium where the atom, the nucleus would be 1 millimeter in diameter. The electrons would be in the upper level, and most of the volume of the atom would be made up of empty space. So there's the nucleus, and there are the electrons, okay? So most of all atoms are empty space, which means most of your body, this is hard to understand, fathom for some students, is empty space. Most of a solid wall is empty space. The reason you can't just walk through it or see through it is because two things. The chemical bonds hold the atoms together tightly, so it's very solid. And second, light requires a certain amount of space to pass through. And atoms, the space between atoms is not enough space for light to pass through, and therefore you cannot see through a wall. An isotope is an atom of the same element but with a different number of neutrons. So here is a lithium atom, and we're going to talk about how to diagram and the structure of an atom coming up here in the next lesson. And this is a lithium-7 atom. So the lithium-7 means it has 7 protons and neutrons. These are called nucleons. And so it has 7 nucleons, protons plus neutrons. This is a lithium-6 atom. So lithium must have 3 protons to be lithium. That's what defines it as lithium. But this second lithium atom has only 3 neutrons. So different atoms can have different numbers of neutrons. Now here's a different notation for lithium isotopes. Down at the bottom is the atomic number. We're going to get into the definition of that very shortly. And it has 3. It's 3. That means it has 3 protons. Up at the top is the total number of protons and neutrons. So for lithium, the lithium on the left, it's 7. For the lithium on the right, it's 6. The mass number, the mass of a specific isotope, is on top, and the atomic number is on the bottom. An alternate notation for an isotope is, as you saw, lithium-7. They assume that you know lithium must have 3 protons, so they just give you the mass number there. Lithium-7, total of 7 protons and neutrons, and the one on the right is a total of 6 protons and neutrons. Another way an isotope can be expressed is shown here. The atomic symbol is followed by the mass number. An ion of an element is an atom that has a different number of electrons than protons. So isotopes have different numbers of neutrons. Ions have different numbers of electrons. And ions are far more important in the study of chemistry than isotopes. And we'll get into that. So here is a lithium atom, again, a normal lithium atom, lithium-7, and you can see it has 3 protons and 3 electrons. They balance each other, and that's said to be electrically neutral. If you look at the one on the right, it's lost an electron, and why and how that happens we'll discuss later. But it has 3 protons and only 2 electrons, so that is an ion of lithium. It has a different number of protons than electrons. The lithium atom on the left has 3 protons and 3 electrons, so the charge is balanced, and the atom is electrically neutral. The lithium atom on the right has 3 protons and 2 electrons, and is a positively charged ion. An anion is an atom that has more electrons than protons. So if you count the protons, the positive charges in the middle, there are 9. If you count the electrons on the outside, there are 10. That means it has more electrons than protons. That means it is a negatively charged ion called an anion. This fluorine atom is an example of an anion. It has one more electron than proton. An anion has a negative charge. So just remember, this grumpy guy is a negative antion. Okay, so anions are negative. A cation is an atom with more protons than electrons. So the example was the lithium atom we saw in the previous slide. This lithium ion is an example of a cation. It has 3 protons and 2 electrons, which gives it a positive charge. So this dude is a positive cation. Okay, so cations are positive. Okay, and that takes care of this brief lesson on the structure of an atom.